Hi everyone, my name is Praveen Vanka and I'm a systems engineer here at K10. Thanks for joining me today to review a commonly asked question. Customers generally want to know how K10 helps with restoring applications in a cluster that's spread across multiple availability zones. Normally, this process involves manual intervention and custom scripts. However, with K10, we can automatically overcome this challenge. While transforms can be used to manually invoke this, today's video will show you how simple it is to let K10 automate it for us. By the way, if you aren't already familiar, Casting K10 is a Kubernetes native data management solution focused on solving day 2 problems, specifically data protection. Our approach allows us to achieve additional business outcomes such as disaster recovery, application mobility, and migration, regardless of the infrastructure and Kubernetes distribution. To find out more details, please review the introductory video link provided in the comments section. In today's lab environment, I've already got a cluster with the test MySQL application and K10 installed. At a high level, I'll validate my setup, simulate a failure, use K10 to restore MySQL into a working node in another zone, and verify that this process completes successfully. Let's run a few commands in the terminal window to the left to validate that I've got a 3-node cluster spanning across multiple availability zones in the same region. We'll now look at the test application, MySQL, to ensure that its default PVC, which is of 8 gigs in size, is attached, and the corresponding volume is also in the US West 2C zone. Note that this is the same node where the application workload is also running. Next, we want to leverage K10 to take a backup to ensure we have a point in time to come back to. So I'll go ahead and create an on-demand snapshot with the default settings. We can monitor its progress on the main landing page. Now that the backup job is complete, you'll notice that we protected the application workload, its config, and data in the volumes. Now let's assume resources in the US West 2C zone are no longer available either due to a disaster or an outage. We can simulate this by retrieving the node on which the application pod is running and cordoning it. Cordoning is a Kubernetes feature that prevents new workloads from getting scheduled onto that specific resource. Let's verify that the node has been cordoned. Assuming a failure of this node, we'll now let K10 restore the application automatically into an available node in either availability zone by selecting the restore point to restore from and leaving all the default options. Similar to the backup job, we can go ahead to the main landing page on the dashboard to view its progress. Please note that K10 simplifies all complexity and keeps this process transparent to the end user. At a high level, because K10 understands how this application works and its components work together, it creates new resources, mounts the volume, restores data to ensure that the application comes back in a fully working state with the data intact. This entire process is automated and eliminates the user's responsibility to stitch data with its application config at a point in time. Okay, so the restore job is now complete. So we can verify that the pod and the volume have been restored, as well as the application, onto another node running in a different availability zone. So what we need to do right now is let's go ahead and get the IP of the node where the workload is running. We'll make sure that they are different. Then we'll go ahead and get the volumes to ensure that it's in fact a new volume and new resource. You'll see that the volume ID changed. And lastly, we'll double check the availability zone that the volume is in, which should be different than the US West 2C zone. Hope you found this video helpful. Thanks for stopping by.